Okay. Now, next one we are interested in free vibration. So, right now just we consider the free vibrations are the vibrations where we are talking about once a system is set into the motion or vibration, that system can continue the vibration and without any decrement in the amplitude, and whatever may be the frequency, that frequency is known as free frequency or natural frequency. That is what we will see little bit in detail what are the free vibrations and what are its characteristics. So, if the external forces is removed or external forces are removed after giving an initial displacement of the system, then the system vibrates on its own due to internal elastic forces, such that such a type of vibrations are known as free vibration. That is what we said in the previous slide also. When we are talking about there are no external forces. No external forces means there is no any resistive force due to air, and that means we are talking about the ideal case. Ideal case means when we are dealing with a vacuum medium. Okay, once we set the system into the motion, then that system continue to its vibrations infinitely many long time, and that is what we call the free vibrations. Okay, so here we are saying that let us consider this particular box, yes, having or a block of having mass m, which is fixed at a spring k and this end is fixed. Yes, this is what we know, linear harmonic oscillator. Okay, now this is what the original mean position, or yes, that particular distance is x equilibrium or x mean, we can say. The same diagram here also we have taken, but yes, this is little bit simulation, you can say how it is. Yes, this was x0 was the mean position and it goes to the another position or displaced due to this particular distance or displacement x. Let us consider this body also displaced by the displacement x and then released. Yes, after displacement and release, and let us say this body is kept in, or this system is kept in vacuum. Then once we release by taking it to the displacement x, it takes the vibrations continuously because there is no any external force. X0 is what the mean position, but x is what now the extreme position, and not only it comes to the extreme position, it again comes to the another extreme position also. See here, it goes to the extreme position, again it comes to not only the mean position, it does not stop at the mean position, it goes to the another side extreme position. And also obviously this type of motion is what our vibratory motion. Moreover, that vibrations are continuously what we can say that those vibrations are continuously taking place and without any external force. So, such vibrations are known as free vibration. Yes, that is what we have given here. Our initial example we have taken a simple pendulum which is taking oscillations in a vacuum. So, it will take the oscillations without any external force, and that is what. And yes, obviously this frequency of vibration is known as free frequency or natural frequency, and we can take that frequency as omega divided by 2 pi, and its unit is hertz frequency, we know that, or we know omega is equal to 2 pi n or 2 pi f. Okay, right. And now what are the characteristics of our free vibrations? So, the system oscillates with the constant frequency and amplitude, obviously because there is no decrement in amplitude, therefore the system will have same amplitude which was for the first cycle. Let us consider for first cycle this will be the amplitude, at the last cycle also system will vibrate with the same amplitude. That means there is no decrement, or we can say the constant amplitude. Moreover, the frequency of this vibration is also constant, right. And the system oscillates with the natural frequency. Yes, the natural frequency or free frequency, that is what the first time we are giving it, and then that will be the its constant frequency, and that is what our natural frequency. And the total energy of the oscillator remains constant, obviously because everything remains constant, therefore the total energy of the oscillator also remains constant. Okay, this f is equal to minus kx is what the force, we know that this is what we call simple harmonic motion, right, because the acceleration or the force is always directed towards the mean position. Thus, that negative sign indicates this negative sign in kx. K is what spring constant, we know that minus sign indicates that acceleration is always directed towards the mean position. That means always that body try to pull itself towards the mean position, and such motion is called as simple harmonic motion. Moreover, this system is called as simple harmonic oscillator or linear harmonic oscillator. Since we are talking about only one dimensional, that is why it is known as linear harmonic oscillator. Okay, so this is all about free vibrations, right. Now, next again we have some types of free vibrations. So, free vibrations not only happen in one direction, but depends upon the, or generally depends on this 3 diagram, you can say, or by looking at this 3 diagram we have 3 different types of free vibrations. Okay, so first one is longitudinal vibration. So the first diagram you can see longitudinal vibration means the simple pendulum is, let us consider the simple pendulum or the bob of the pendulum is not attached to the string, it is attached to a spring, and yes, that simple pendulum is taking vibrations in a vertical direction or the axis to which it is fixed. Now see, this is what the axis at which it is fixed, and yes, it is taking the vibrations in that direction only. We can say it is taking the vibrations parallel. Yes, see, the statement moves parallel to the axis of the shaft or where it has been fixed. So if it is taking vibrations parallel to the axis, then that are what we call the longitudinal vibrations. By looking at the diagram only, you can see this B is what its mean position, A is what the extreme position, and C is another extreme position. Okay, so it is taking vibrations in vertical direction and the axis is also vertical, that's why this is what longitudinal free vibrations. Okay, because we are talking about free vibrations. Second one is transverse vibrations. Obviously in the name itself we can say transverse means it is perpendicular, so but perpendicular to the axis. Now this vertical is dotted is axis, perpendicular axis. Now it is taking the vibrations likewise, whatever we have seen the simple pendulum in the previous slide. So that is what the transverse free vibrations, because it is taking perpendicular vibrations to the axis. Now this is what the axis to which it is fixed and it is taking vibrations. So yes, this is exactly perpendicular to our axis, and that's why it is what called transverse free vibrations. And one more are there, one more is there, that is what the torsional free vibrations. So torsional means what? We know that if we attach a disc, right, if we attach a disc, now that disc is taking vibrations like this. So this is what the, or these are what the vibrations of the disc. So now this disc is not taking any perpendicular vibrations or not taking any parallel vibration, but it is twisting about the axis. The disc is twisted about the axis, and that type of particular vibration are known as torsional free vibrations. So these are different types of free vibrations, depends upon the only how it is taking vibrations with respect to the axis, fixed axis, or we can say to which it is attached. Okay, right. Now again here we have two different kinds of free vibrations, undamped free vibrations and damped free vibrations. So here we can see, now these are what the undamped free vibrations. Now see here, there is no decrement in amplitude of these oscillations or these vibrations. See, from where it is starting, it comes to the that position again and again. That means there is no decrement in amplitude of vibration. So this the same spring I have written here steady, or I have drawn here steady diagram. This is what the simulation we can say. Likewise, the spring or that block is taking vibration with the help of this spring. And yes, let us consider this. Initially this was the diagram, that means this was the position, mean position. This horizontal axis is the mean position. Okay, so at that mean from that mean position we bring the system to this external position initially, and once we release, it goes to the mean position, again to the another extreme position, then mean position, extreme position, and likewise. So it is taking the oscillations continuously. And if we are talking about the amplitude, yes, this particular distance means this extreme position and this extreme position, that particular thing we call it as amplitude. And here for this is what the first cycle, this is second cycle, third cycle, you can say for every cycle amplitude do not decreases, right? So such a motion or such a vibrations or such a free vibrations are known as undamped free vibrations. In a free vibration there is no external, it is not on, here it is no, there is no external artificial resistance to the vibrations, then such vibrations are known as undamped. There is no any artificial resistive force, no air resistive force, nothing is there. The system is taking vibrations continuously without a decrement in its amplitude of vibration. So such a motion or such a vibrations are known as undamped free vibrations. Okay, and on the other hand, damped free vibrations. So damped free vibration means here in this diagram only you can see, along with the spring, along with this spring we have one damper. This is known as damper, that means that is responsible to decrease the amplitude every time. So that damper, here it is artificial damper, sometimes not necessarily artificial if we are talking about this motion only, and if we keep that particular system into the air medium, obviously the air resistive force acts as a damper. Yes or no? If we keep that system into the water, then water resistive force acts as a damper, or water itself acts as a damper. So here let us consider we are talking about the vacuum medium only. So for that we have to add one artificial damper. Here it is, means after every time that damper tries to decrease in the amplitude, and yes, the graph of the undamped is like this, there is no any decrement, but here you can say for the first cycle the amplitude is more, for second cycle amplitude decreases, for third cycle decreases, and yes, the amplitude goes on decreasing continuously. Such motion is known as damped free vibration. So here the same diagram, whatever may be, we have drawn here steady diagram, and here this is a simulation, we can say here. So likewise, now look at this. Yes, amplitude goes on decreases, and every time that damper tries to decrease the amplitude, that is what we call the damp free vibrations. Okay, so simple here, that damper is because of friction, always try to bring that system to the mean position again and again, and after every cycle, yes, this damper you can see here, it is like a friction force is there, and that friction, due to that friction, yes, obviously there is loss of energy, and therefore after every cycle the system or this block cannot goes to that extreme position from where it has been started the motion. Yes, because yes, if you are starting from that point and at this particular position you have some frictional force, then you will lose energy here. So for the next cycle that block cannot go to that extreme position, it will come to a little bit closer to this particular mean position. Again for the next cycle it will come to the closer position, closer, and after some time, yes, the system or the block cannot move from its original position, that means cannot vibrate, and therefore the vibration we can say becomes dead. That is what we call the damp free vibrations. Okay, so that's what I have written here. In a free vibration system, resistance is provided to reduce the vibration, then the vibrations are known as damp vibrations, more or damp free vibrations. Okay, right. Next is forced vibrations. Yes, whatever we have seen till now, that is about the free vibrations. Free vibrations, we have seen 3 different types of free vibrations, and moreover in that damped free vibrations and undamped free vibrations. Now forced vibration. So what initially I told about the forced vibration means after, or you need to apply a periodic force to the system so that system can continue its vibration. That is what we call forced vibration. Here now look at this, every time one arrow you can see, either it is going in downward direction or in upward direction, that arrow is nothing but the external force we are applying. Okay, that means what, the spring and this block is taking vibration, but after every time, you know, yes, we are applying, after every cycle we are applying some external force either in downward direction or in upward direction. So that force is only continuing the vibrations of the system or vibration of that spring and block system, and that's why such vibrations which are due to some external force or which are under the influence of external applied force are known as forced vibrations. If the system or a body is subjected to a periodic external force, yes, obviously we are applying after an equal interval of time, that's why we call it as periodic force, then the resulting vibrations are known as forced vibration, and whatever may be the frequency of that applied force, that is only the frequency of the vibration of system. That also we have seen. And when an external force is acting, the body does not vibrate with an own natural frequency, but vibrates with the frequency which is equal to the frequency of applied force. So here in these 3 examples we are applying a force, and that force is actually where, here whatever may be, this arrow is a force, this arrow is a force, this arrow is also a force. That force, whether sometimes it is in downward direction or sometimes it is in upward direction, yes, obviously you can pull that block from the spring, this is what the force in upward direction, and when we release and we feel that yes, now the amplitude goes on decreasing, then next time you can yes, or in second system we can apply to downward direction. That means when the system is taking oscillations, taking vibration, within that time also you can have some jerk to the block. Yes, if we have the jerk, that will be the force in downward direction, that also yes increases in the amplitude, or that will also helpful to the system to continue its vibration, and that's why here we call such vibration when we applied either downward force corresponding to this system. Not necessarily you should apply the downward or upward force. If the system is taking oscillation in a horizontal plane, then you can either apply force to the positive x axis or to the negative x axis, depends on the system. Now for this particular system we are talking about, we are taking the vibrations, or the system is taking vibration in vertical plane. That's why yes, either you can apply the force in upward direction or in downward direction, and due to that force only the system is able to continue its vibrations. That type of vibrations are known as forced vibration. And yes, obviously the system is also taking the vibrations with frequency which is exactly equal to the frequency of external applied force. Okay, yes guys, I hope you got it. This is all about the today's video. Yes, what we have seen here, forced vibrations and free vibrations, but in that free vibrations we have a little bit more categories: free undamped vibration and free damped vibration. But yes, this is all about our today's class and or today's video, which is free and forced vibration. I hope you got it, and yes, obviously if you have any doubt you can post in the comment box. And if you really like this video, if you really feel this is what I got some knowledge, it is addition to your knowledge, then obviously please like this video, and for more such videos please subscribe to my channel and press the bell icon so that you will get the notifications of my next videos, right? So thank you for watching this video guys. We'll meet in the next video very soon. Till then, you please take care and keep learning. Thank you.